I said our Google camera is not, you can't see it. You had to print on a photographic film. We ordered the photographic film, but it didn't come out yet, so.
Oh, okay. Well, when it gets here, I'm interested in seeing that.
Next week I'll bring more photographic film.
Sure.
So
Very
you gotta
cool.
Put it, first you gotta put it in the developing film, then you gotta put it in the stopping liquid. And after that, you gotta put it in the fixing liquid, and you gotta wash it.
Wow.
Yeah.
Wow.
Does the camera actually have to take pictures?
No, it usually just projects an image.
You gotta open the shutter and close it.
It was super tough for me.
Yeah.
My brother was doing it so easily. I'm like, how are you doing that? He even helped me for one step.
Oh
I
my.
was supposed to tear the templates apart, and I'm like,
No, my goodness. Really?
I was 3D printing mine, and I had trouble designing it.
Oh my.
Was it the video you sent? A 6-minute video with the.
Yeah, I think so. Yeah, I put that in there a while ago. I don't remember exactly what video it was.
It showed a baby photo and there's something.
Yeah.
I thought this camera would take pictures and some of it.
Let me see.
It's a.
Which end do I look in?
Oh.
This one.
This one.
That first. Oh, okay. Oh. And that's where the light's coming in.
Oh, yeah.
So this is.
You
Where do I
gotta-
look? Do I look
Through this one.
through?
Yeah.
Mhm.
I think
You don't look at here, it's just like a camera. You have.
Oh, you're gonna actually go and put it. Oh, okay. Don't let it break then. Be careful with it because you put a lot of work into that. Oh, that's really cool.
bent like.
Yours too made a shutter. That is really neat. The two I have already are James and Caitlin's. James is very fancy because he 3D printed it. But this is James, but Caitlin works, yeah, Caitlin works better. So if you look at that window and the shape of the window, you can see it's like a moon shape, right? Like a half moon. And if you look through here, it goes upside down exactly like it's supposed to. You see it flip upside down, the light?
Yeah.
And it's that.
Wait, can I write my name here? I don't want to
think
get
that
mixed up. Too
Yeah.
light of a filament.
I'll show you guys later. It's pretty cool.
We can use too light of a filament.
Yeah, I think that actually, yeah, it needs to be a darker color. That would help a lot.
I'm
Black
gonna
and
use
white.
purple, so because that's a darker filament.
Yeah.
has a 3D printer.
I guess it
never knew
does.
that. I have a
But
3D
this one,
printer.
you can really see it, like, it works really well, it's
You know?
upside down, yeah. It's upside down, just like it's supposed to be, see it?
Oh, yeah.
And that's exactly
Can I put
right.
it inside there and zoom it out?
In there, yeah, but don't you wanna take it home to put the film in it?
Oh yeah, I'll take the, oh yeah, I'll just take it.
Yeah, I was gonna say, if your film comes, you wanna have it for next
Yeah.
week.
Yeah.
How's your mama doing?
She's doing good.
She driving?
Yep, she got her license.
I know, she told me, no baby yet.
I know.
Do you know what you're having, a boy or a girl?
Yeah.
It's a boy.
It's a brother?
Yeah.
All
I'm
right,
excited about that.
yeah?
My
I want-
sister's crying all night.
Oh, no,
She wants to
why?
have, she wants to have a sister.
She wants a sister.
It sounds like my brother when she found out, when Jack found out that we were having Reba and she was a girl.
Another girl? He's like,
Yes.
why am I outnumbered? Yeah.
Yes.
Oh my goodness, thank
It's
you.
easy to see on that one because it has such a defined
Yeah,
shape, but when you're looking
exactly.
at like one of those, it's a bit harder.
Yeah, that one's perfect because the shape's real, yeah, like you said, real clear. I'm just keeping them in here to make sure they're safe. They're very cool.
I was doing mine this weekend and I decided I just do it next week.
Do it next week, yeah.
Probably the baby brother is gonna come like around next month, half of
Yeah, probably. Well, I think she said she was due what, like March 13 or March something?
March 17th.
17th. And I said, well, my birthday is the 6th, so maybe you'll have your baby on my birthday. It's a good day. Does he have a name yet?
We haven't decided.
You haven't decided. You better hurry up.
When it comes to procrastination, I'm a between sad.
Oh, I feel ya.
I thought we were lesson 23, but we're in lesson 24.
24 already.
One more, it was just
Hey.
about-
Yeah, here, 24.
I'm on time for once.
Here, I'm not.
And I am early as always.
My family doesn't do early.
I'm always the second to do early. If I'm on time, I'm late. You should try going to me with to RDOs. I will be rushing you out the door to make sure we're early.
Oh, I'm still rushed out the door.
Yeah, but you can ask my little sister. Let's just say she's not the happiest when I'm rushing her out the door in the morning.
No, I don't like rushing out in the morning either. I'm
Yeah.
not good at that.
We don't rush. When we go to our sports, we just leave for a place that's 15 minutes away. 10 minutes before the class starts and drive 60 round corners.
Well, there's that. You can always do that. Yeah.
That's our go-to.
Yeah, I'm not great at the rushing thing. I like to be very early, but I used to be early all the time, and then I guess I got tired of being early all the time, so now I'm not early as much as I used to be.
I'm good controlling me and making sure my grandma, but when it comes to little sisters who don't like to obey you,
Oh,
that's a
well,
whole different. Are you the biggest sister?
yeah.
I'm the biggest
Just
sister.
cute little sisters, but then Jack's older than her.
Sure y'all know my brother.
I don't know, you've not met Jack, have you?
Yeah, I've met Jack and the Devil once.
Oh, that's right.
Oh, he was there when me and Lewis were here.
Yep.
I'm the biggest sister.
You wear glasses, I think it's like 5'8".
I don't know how tall Jack is now. How tall is Jack now?
Take a tape measure to him while he's sleeping. He's
do that.
really fat. I could still his ski though.
No, he's just tall and he's a sturdy guy.
Jack drew us the ice cream last week, which was fun.
Did he? It's so fun when your sibling gets to drive and you get to do cool stuff.
And you get a personal Uber.
Yep.
That's
Personal
how I'm
Uber.
gonna end up. 2 years.
Driving this dude around,
Yep.
driving him everywhere. Daggone. Jeez.
I have to go to the store for my parents then. Yay.
Yep.
When I get my dad's gonna be like, get me to my game. My mom's gonna be like, get me to some doctor appointment or something. My sister's gonna be like, get me to my art class. And it's gonna be like 9 o'clock in the evening and we're like,
Oh.
when I get
no.
we're leaving when I wanna leave, not when Nora wants to leave. We're leaving when I wanna leave because I have the power to leave her at home.
Who's harder to get moving, Nora or Reba?
Nora, because it's hard. Okay, so it's harder to get Nora moving because she usually sleeps in, but it's harder to get Reba moving because she's the littlest.
Ah, how old's Reba now?
6.
Yeah, I was gonna say about 6 or 7. Okay. Well, cool.
But it's hard to get Nora moving.
Mm.
You start the class with Don Carlos and Nico.
They should be here in just a second.
I thought
I'm looking to see if
yesterday.
I see any messages from them.
If the door opens, that means it's definitely most probable. So. Small talk. Small talk, that's small talk. Yes.
That's how I talk.
But I love to talk.
Oh, I stepped on one of my dog's sharper toys and ripped back a flap of my skin. Like for my,
Ow.
yeah, but it's like pretty much closed up, so I can practice for my competition tonight.
What are you doing?
Gymnastics, I have 2 more practices until my competition.
What level are you?
My gym doesn't like do levels. I'm intermediate at the moment. Like,
So it's not a USAG competition.
no, it's
What is it?
not. It's just like an internal competition.
Oh,
yeah.
yeah. Are you competing all 4 events?
No, I'm only competing 2 of them because my floor is not good.
So what else are you not competing?
We aren't doing beam anymore since the accident in 2017.
Oh,
Yeah, like some person.
where do you go?
Jump fancy.
Oh, okay.
Yeah,
Yeah.
so I'm just,
What's your bar routine?
we do trim because a lot of the kids competing are obviously not tall enough to reach the bars.
Yeah.
So, I do tramp and double mini. That's my-
Oh, okay, so you're doing, I see, you're doing tumbling,
Yeah.
okay, trampoline and tumbling.
Yes.
That, they have USAG trampoline and tumbling. Yeah.
Yeah, that's what I just have to work on my back.
Well, actually, when we were in Texas 2 weekends ago, they had, it was a big, huge meet. They had a women's meet, a women's collegiate meet, a men's meet, and a trampoline and a tumbling meet. So they had everything going on at one time. It was cool. If you need help with that back handspring, you know, both Drew and James can help you with that.
I know, I injured some muscles
Ow.
after I landed on my head, so I'm trying to
I'll do
build
that.
back up to it.
Yeah. Alrighty, let's get rolling. Those boys should be here in a minute, I'm sure.
Like my answer for my homework.
I haven't looked through them all yet. I looked through some of them.
Mine, you said which people would bring to an island. Mine's would the rock.
Yeah, I
That's
saw.
all I
yours.
need.
Yeah, there you go, there you go.
I have Bruce Lee,
Mm-hmm.
Vladimir Putin because of his like weapon power.
That's a good one.
And I also have Albus Dumbledore as Albus Dumbledore.
Very good. So, something for everybody to keep in mind when you're doing homework or tests, okay? If there's an answer that asks you like a free, it's like a, open-ended question, like a free response, I can't possibly plug in what you're gonna answer for auto grading. So it's gonna mark it wrong. Okay, but when I go back and grade it, I change it, right? And I usually put in manually graded for an answer.
Just say something.
Yeah, so this time I forgot to type in the words manually graded, because I figured by now, well, and also kind of figured everybody knew it by now. I got like so many emails. Oh my gosh, my question was wrong. And I'm like, no, I don't know what you could, I can't put in, I can't guess what you're gonna write for an auto grading. All right, let's get rolling. So we're gonna start off talking about electric charge and static electricity. This is one of my favorite AI images ever created. He's got socks on his feet.
Like every time.
Yeah, but this one wins. Anybody ever experienced this phenomenon?
Yeah.
Wearing socks and you touch the doorknob and it gets you? Fun times, right? Yep. All right, so the charged parts of atoms are protons. I think it's the same tail, it just loops around. The charged parts of atoms are protons and electrons. What kind of charge does a proton have, Lewis?
Positive.
And what kind of charge does an electron have, Carlos?
Negative.
Negative. Okay, very good. How do you remember that? Darcy?
Protons, so P for positive and electrons are opposite.
There you go. And then what about neutrons?
Neutrons is neutral.
Neutral. So it's easy to remember that way. So charges that are the same repel each other and charges that are different attract. Opposites attract, right? So if you have electron and electrons, they're going to repel, but electrons and protons are going to be attracted to each other. All right, so electric charges are surrounded by what? What do they produce, Eunice?
Electric field.
Electric fields, okay. And these fields surround single and multiple charges. So let's have a look here. These are electric fields of individual particles. So I'm probably going to clear my throat and cough a bunch today. I'm not sick, but I had a cold and now it's like everything's just, yeah, it's not even that. It's like a nerve thing. It's weird. So anyway, here's what kind of particle is this, Darcy?
Proton?
That's a proton. All right. And it has a positive charge all around it that it's exuding. And this one is yep.
Electron.
That's an electron. All right. So when you put them together, a positive and a negative, you can see that they're both spilling those fields out all around, but these are going to be attracted to each other. But when you put two positives or two negatives, they're going to repel. And here's another example. If these were little pendulums, you could see these negatives are going to repel, positives are going to repel, neutral is not going to do a darn thing, and then positive and negative will attract, right? All right. Now, who's played this game before? Yeah, okay, with a balloon. We're actually going to do it in a minute. So what's the buildup of charges on an object? Okay, Darcy.
Static.
That is, okay, static electricity is the buildup of charges on a object. Hello, words in English this morning. In static electricity, charges build up, but they don't flow. What does the word static mean? You know what static means? Do you know?
Still.
Yes, perfect, Carlos, still. Okay, so charges are not flowing, they're just sitting there. They've built up, they're static. All right, so charges are transferred in 3 ways. What do you call it when electrons are like rubbed off of one object? All right, Nico.
Induction.
No. Friction. Okay, so if you rub, it's friction, right? So if you rub charges, so if you do this number where you go, and it starts to get, oh,
I'm not gonna die.
why does my hair stick to the balloon?
Static?
Right, but what's going on with the charges? What's getting rubbed onto the balloon?
It's like changing the charge.
Yeah.
New protons.
No.
No.
I think your
Electrons.
hair.
Electrons. So why, let me ask you this, why is it the electrons that get rubbed off and not the protons or the neutrons? Think about structure of an atom. do you think?
Because your hair doesn't have any charge.
Well, yeah, it doesn't when I start rubbing it, but why, how come I can make the electrons come off? Why don't the protons or the neutrons come, like, why don't they rub off as easily like this?
Protons have a positive.
Where do you find protons and neutrons in an atom?
In the middle.
In the nucleus, right, okay, and then where do you find the electrons?
Circling around it.
So, yeah, so they're circling around, and if there are some that are not tightly bound, they can come off, right? There you go. All right, so let's stay there right now. All right, we'll leave him there for a minute. Maybe. Gravity, different force. All right, so what do you call it when electrons are flowing from one object to another, Carlos?
Conduction.
That's conduction. And that makes sense, right? We talk about electrical conduction. We've talked about heat before, right? All right, and then transfer of charges without contact. What's that one, Emma?
Induction.
Induction. All right, that's good. So though charges may move, they're not created, only transferred. Does that sound like something you've heard before?
Yeah.
What does that sound like?
A lot of energy where it cannot, or the conservation.
Yeah, law of conservation, which is,
Law of conservation, which states that energy cannot be destroyed or made, only transferred.
yep. What's the law of conservation of energy? She said it. That energy cannot be created
No, just.
or destroyed. It only changes form or transfers form. Right, okay. And then what about mass? Do we say the same thing about mass? Yeah, we do actually. Yeah.
Because mass and energy can be converted.
And matter. We say matter too. These are all conservation laws, all right? So static electricity can cause objects to stick together. All right, so when a negatively charged object and a positively charged object are brought together, electrons move until both objects have the same charge. The loss of static electricity as charges move off an object is called what? What's that, Carlos?
Static discharge.
Yep, that's the zap when you touch the door handle, right? That's a static discharge. Everybody's experienced that, right?
Like going on a slide.
Yeah, and you're going down the slide, and it's like zapping you the whole way
It's
down.
from the little screws that just go.
Yeah, zap, 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 and you're like, geez,
Oh.
you ever done
Such
it?
a metal thing.
Yeah.
And I get zapped and I fall down.
Have you ever done it in the dark and actually seen a little spark?
Yes. I rub my blanket on my hair and
Oh.
put my finger in it like
Yeah, have you done it?
when sometimes when it's dark and you get your golf club on the mat, it creates a spark.
There you go. All right.
When.
So this is what happens when you shock someone. Oh, wait a minute. Shock someone.
Yeah,
You mean
you
you do it on purpose to somebody else?
We
Who's
do
done
play
it?
That game.
Who's done it
All
on
the
purpose to
time.
somebody else? Emma's the only good girl among us.
I got on the
You're the only one?
Here.
You have two little sisters to torture. You haven't done a little.
I chopped it.
No?
I chopped it myself.
You shock yourself? Oh, well, you can do it to somebody else for sure. So it's like that should say bolt of lightning. The lightning you see in a storm is a static discharge. It's just on a really big scale. So that little zap that you do is the same thing that happens during a thunderstorm, a lightning storm. It's just much, much bigger and you can really see it. Okay, so we're going to talk about an electroscope and then I'm going to show you one. But first, it's an electroscope because I just said that. All right, so watch this. I've built one that we can play with too. It's pretty cool.
Hi everyone. In this video, I want to take a look at the interaction of a charged PVC rod and an electroscope. We need a PVC rod, a woolen cloth, and an electroscope. First, rub the woolen cloth vigorously on the PVC rod. Before the rubbing, there are as many positive as negative charges on the PVC rod and on the woolen cloth. Since the two charges balance each other out, both bodies appear to be electrically neutrally charged. When rubbing, some negative charges are transferred from the woolen cloth to the PVC rod. As a result, the PVC rod then has more negative charges than positive ones and is now electrically negatively charged. The electroscope has a metal cap on top. First of all, there are as many negative as positive charges. Under the metal cap, there is an insulator that prevents charges from being transferred to the outer case. The metal cap is connected to a metal rod to which a freely rotating metal needle is attached. Here too, there are the same number of positive and negative charges. If you approach a negatively charged PVC rod to the electroscope, some negative charges are repelled downwards. As a result, if there are more negative charges than positive charges in the lower part of the metal rod and the needle. In the upper part of the metal rod and the needle, there are more positive charges than negative ones. The lower parts repel each other because here the negatively charged lower part of the metal rod and the negatively charged part of the needle are close together.
And then it's gonna spin.
The upper parts repel each other because the positively charged upper part of the metal rod and the positively charged part of the needle are close to each other. Thus, the needle deflects. If you remove the charged PVC rod again, the negative charges are evenly distributed over the electroscope. Both the metal rod and the needle are again neutrally charged and the repulsive force disappears.
Okay, so we built one. This is a little different. So if you look in here, there's two teeny pieces of foil, aluminum foil. You see those? They're on the bottom of that wire. All right, now the wire's insulated. You see them? But I have filed off the insulation on the bottom of the wire where it touches this and up here. Okay, so and then I have right here like a big disc, right? I've wound the wire around in there and then I covered it in foil. What do you think is gonna happen? If I hold those electrons back up my hair again, you get the balloon close to that little circle.
They're gonna.
They're gonna push apart. Can you see it, Candace? Maybe that, you see it there? Okay, let's see. I'm not even that close to it, am I? You see it moving?
Oh my god. What happens if you touch it?
I'll just keep moving.
That's so cool.
It's like wah 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 wah
Maybe
wah
not.
wah 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 wah. Isn't that wild?
Like saying that.
I am a homemade electroscope. Wow, right? See? Now my hair's gonna be crazy all day. So you can make that yours. That's easy. You can see how I made it, right? It's just a piece of cardboard at the top. And I ran the little wire through it, filed the bottom, and it's still holding some charge.
Wire or
because they're still
paper
repellent.
clip?
It's a wire. It's called magnet wire. It's enameled copper wire. And we'll be using magnet wire in a lab coming up in the next few weeks because we're gonna make little tiny motors, electrical motors. Everybody will get to make one. So the instrument that detects current is called a galvanometer. Go to the next page. Hello.
Remove the PVC
No, we're good. We know.
rod.
Shush. All right, circuit measurement. Now we're gonna talk. Look what I'm wearing, by the way. Did anybody notice? I have circuit leggings on today. Boom. That's cool, right? All right, circuit measurement. So we previously learned about gravitational and elastic potential energy, right? So what do you call the potential energy per unit of charge within a circuit? Oh, look at all the hands. Eunice.
Electric potential.
Yes. Okay. So we had electric potential energy. We had gravitational potential energy. We had another one. You think?
Potential distance?
Oh, we didn't. No, I asked you a different question. In the past,
Elastic gravity.
there's elastic, gravitational. There was another one. Do you remember we talked
air
about
powers?
chemical? Chemical. Remember like food?
Okay.
Yeah. Okay. So, so what is the difference in the electrical potential between two places? All right, Carlos. There you go. Your potential difference. All right. So your potential difference is measured in volts, and therefore it's called, Lewis, voltage. Okay, voltage causes current to flow through an electric circuit. All right. This brings us to one of my favorite stories. This is this lesson's great smackdown in science. Are you ready for a wild story? I'm talking wild, y'all. This is pretty wild. All right, so we have this guy. This dude is named Luigi Galvani. He has an excellent wig and a lovely cravat. Yep. So look at the years, 1737 to 1798. Okay. Galvani here, he's an Italian guy. You couldn't have guessed from that name, right? Sounded really German. Galvani. No, he didn't. So he was a physician, a biologist, and a philosopher. What do you call people that have a large range of knowledge in varying areas? Do you remember? Polymath. Very good. A polymath. Okay. So he was kind of leaning towards a polymath, but he's stuck a lot with life sciences. All right. But so once while experimenting with some disembodied frog legs.
What?
Yep. His assistant charged a metal dissecting tool with static electricity from a Leyden jar and touched it to the frog's legs. Now, Leyden jar is a static electricity generating machine. Okay. What do you think's going to happen when he touches the frog legs? Oh, yeah, they jumped. Okay, they like kicked. All right, so this began this dude's fascination with what he termed bioelectricity. This is a great story, you guys. Okay, so this is a diagram of what he was doing. Like you can see, it's not to scale very clearly because there's the hand up there touching the Leyden jar, which says letter B. And then down here, here's the hand touching those massive frog legs, clearly not to scale. God help us if frogs were that big. I'd be terrified of them. So that's a little graphic. All right, now, he got really, really curious and he started to place the frog legs outside and ran wires from them. So historically, this has taken place after Benjamin Franklin with the key and the kite. Y'all have heard that one, right? Benjamin Franklin, the key and the kite, lightning, zzz, whole deal, right? So what do you think he's doing? Why is he doing this?
Make it like live with electric charge.
Maybe. All right. So imagine this guy is your next door neighbor. You're minding your business and this is going on next door. Yeah. I mean, it's a little weird. Okay. It's about to get a whole lot weirder. So really weird. So you need to picture this. All right. You're strolling past Galvani's home. Now, this is actually Galvani's home from the late 1700s. It's still there.
Oh, no.
But you got to imagine no cars, no modern street. All right. So we've made it better. All right. So it looks like this. Now, anyway, you're strolling past and you notice Galvani's lovely home with this beautiful wrought iron fence around it. And it's a nice stormy day beneath these stormy skies. And you see this. Not kidding. You're walking to market to mind your own business and pick up some potatoes for dinner. And dude's got frog legs hanging from his fence all over the... Just seriously imagine this. You're minding your own business and this is what you're seeing. Like...
The real question is where did you get so many frogs?
So this is real life. Like this is what was going on. Never doing like that kind of deal as you walk past.
That's Halloween decoration.
Yeah, it kind of is Halloween. All right, so now it gets even a little, it's about to get crazier.
Next Halloween, you should totally do
Oh,
that.
Galvani, it's gonna get crazier than that. So he believed this whole phenomenon was something he had discovered called bioelectricity, okay? So it's this electrically charged body fluid that the brain generates and it flows through your body and it's in this state of disequilibrium. And he's like, I have found a way to reanimate a corpse. Look at this. Like he's thinking he is pretty awesome. What he'd actually discovered was that a frog's nervous system transports charges. So does yours. That's how nervous systems work, right?
If we were dead and someone chopped off our legs, hung them to a fence, that would happen.
Oh, just wait. Just wait.
Wait, he did that?
So he charged metal, and that charged metal is completing a circuit. Okay. So he knew that metals transmitted electricity, but that it came to this obvious, to him, obvious conclusion that this is called animal electricity, right? And it was generated in the tissues of the frog, and it was flowing through the skewer, and it activated the muscles, and ooh, that's what he's thinking, right? So he distinguished this electricity, this animal or bioelectricity, from what he called artificial electricity, which was the Leyden jar, the static, or natural electricity, which was lightning. And he thought, like we said, that it was something flowing through the body. All right. So we know now that electricity is electricity, but he thought he had discovered a third kind. Okay, so this dude, okay, this was a landmark. Scientists understood the nervous system differently now after him. It's a big deal. You can leave it on, honey. So his nephew, this fella named Giovanni Aldini, was his greatest supporter. He thought his uncle was like better than sliced bread. So he was also a very, very dramatic showman. So he traveled all over Europe, reanimating corpses of animals and humans. Yeah.
That's totally
Not-
illegal.
Yeah, totally illegal. Well, there weren't laws. Nobody even knew to make it a law. All right.
Very
So this became known as galvanizing a corpse.
Oh.
All right. So rather than dragging around the Leyden jar.
TV.
Oh, that's weird. What was that? Oh, no.
Somebody's breaking in.
I'm looking. Let me check it here.
5 seconds later, the bird gets done.
I think it's coming back. 1 second.
The bird in the.
Beep, beep. There we go. All right. So this became known, I know, as galvanizing a corpse. Okay, you can see this bull, right? Fun times, no head. So rather than dragging around the Leyden jar, which was a big machine, Aldini carried around what was called a voltaic pile, which was an early type of a battery. All right, keep that in mind. Don't forget that voltaic pile. That's going to be important. But his most famous demonstration occurred in London, January 18th, 1803. So by now, Galvani's dead, but his nephew's still carrying on this stuff. All right, so here's what happened. A 26-year-old man named George Foster had been accused of murdering his wife and his daughter by drowning, and he was hanged that day. All right. So his body was immediately transported to the Royal College of Surgeons in London, where before an audience, by the way, do you know what they call operating rooms in England? They call them operating theaters, and that's because
Yeah.
they very often had an audience. Okay,
Oh, that's.
here's an audience. He starts sticking electrodes from the voltaic pile to Foster's corpse.
Did it set on fire?
Oh, you'll see. So he put him near his jaw and his ear, and he managed to get a one-sided grimace, like a. So everybody's like in awe. This is crazy. He caused an eyelid to open up, and everybody's like completely shocked. Never seen anything like this. This is wild, right? His aim, the reason he's doing this isn't just to be like weird and morbid. He was trying to learn how to save a person's life who'd had some kind of trauma, right? And how to restart the heart. So really, this is the genesis of things like AEDs Right.
Someone's neck.
and defibrillators. You know, like when they say clear, they shock somebody, or you see an AED in public. AEDs are defibrillators, but they're automated. So it's an automated electric defibrillator. So basically, like you put the electrodes on and you stand back and the machine does everything and it talks out loud to you and it says things like place this here, stand back. So you know, right? All right. So this is what he's working on. All right. So, oh boy. But in 1803, he was just kind of fiddling about. And he kept fiddling about with Foster's corpse. And then he moved an electrode to the bottom of Foster's spine. And he sat up. This is a cartoon from a newspaper publication back in the day.
Oh,
And-
it was supposed to be like devils or something?
Yeah, they are. This whole thing, like it said, had I not been born insensible to fear, now should I be most horribly afraid. Hence, horrible shadow, unreal mockery. It's great. It's great. It's very early British. Yeah, very, well, not early, very, very early 1800s British. All right, so he made this dude sit up. So does the idea of a scientist reanimating a corpse?
Frankenstein's monster.
Frankenstein's monster. Okay, so this dude, right? All right, so then do you suppose that Aldini got the idea to do this by reading Mary Shelley's Frankenstein? Do you think maybe that's where he got the idea from? What do you think?
Yes.
You think?
Mhm.
So actually, she got the idea from him. That book was published in 1808. So Frankenstein, when it was written, was not completely out of the blue. This had been going around Europe for a while. People had been making dead bodies sit up. Freaky, right? All right, now, not everybody thought Galvani was absolutely fabulous. He had a professional nemesis, okay?
Well,
And this dude is Alessandro Volta.
the volt.
Ah, very good. It is the volt. So Alessandro Volta was another Italian, and he thought Galvani was wrong about how electricity was generated, stored, and transported. He believed that metals were all that was required, and electricity was electricity, not artificial, animal, or natural. Okay, so Volta was the one who coined the term galvanize, as in galvanizing a corpse to make it move. But he did it with an eye roll, like that dude's walking around galvanizing things.
No.
Like it was a sarcastic thing to say, right? But Volta could reproduce Galvani's results, which means he tried it. But he figured Galvani was wrong about how and why. So Volta created a device, a non-living thing that could do what Galvani claimed bodies could do. And it was a stack of alternating discs of copper and zinc separated by thick paper discs soaked in like a saltwater brine. And it was called, do we know?
A tall double sandwich stack.
Yeah, it's a tall inedible sandwich stack. It was called a, do you remember? What was the name of that thing that Galvani's nephew Galdini dragged around Europe? A voltaic pile. Wait a minute. So yeah, thanks, Alessandro. You invented something to kind of prove your nemesis wrong, and then his nephew used it to go around and gain fame with it. So yeah. Wah, wah, wah. So there's a cartoon with the two of them there. In the end, they were both right about some things. They were both wrong about other things. So neither understood the function of electrolytes. What's an electrolyte? You know?
Put them in your water.
They are in your water sometimes, like Gatorade's full of electrolyte. Electrolytes are basically like ions, like like a sodium ion or potassium. They're things that can allow you to get more free electrons in your body because you need electric charges for your nervous system to work. And they basically feed your body stuff to make your nervous system and your muscles more efficient, which is the point of like Gatorade,
The
right?
question is, where does OHM come into all of
Oh,
this?
we're getting there. Real quick though, the legacy of this whole smackdown in science. So we now have batteries, a much better understanding of neuroscience, defibrillators, EKGs, EEGs, the unit volt, which is electromotive force. Volt measures how much pressure, you can think of volt as pressure in a circuit. The higher the voltage, the more the electric current. And the term galvanize, which as a verb means to shock or excite someone into action. The accident at the intersection galvanized the public to fight for a better traffic signal.
And then
Galvanize, to shock or excite someone into action. Think about that. And the verb galvanize, which means to coat iron or steel with a protective layer of zinc. If you've ever seen that kind of patchy looking metal, like sometimes it's buckets, a lot of that like farmhouse stuff, does that look as galvanized steel?
They both say verb.
Oh yeah, that's what I meant verb. I meant it is a verb to galvanize something. And it can be described as an adjective like galvanized steel because it's been done to it. All right, so what creates a potential difference in a circuit? All right, Carlos, sorry.
Voltage source.
Yeah, a voltage source. All right, is going to create a potential difference in a circuit. A good example is going to be a battery. So just as the increase in difference in height causes a greater flow of water, an increase in voltage creates a greater flow of electric charge. The amount of current that flows within a circuit depends on the voltage as well as the resistance or the opposition to the flow. A current will take the path of least resistance. Think of voltage like pressure, okay? All right, so the greater the resistance, the less current, therefore, there is for a given voltage. So voltage is measured with a Nico. Yep, voltmeter. And amps are measured with what, Louis?
Ammeter.
And ammeter. Yep, okay. And what is named for George Ohm? All right, Eunice.
Ohm's law.
Ohm's law is named for George Ohm. And it states that resistance is equal to voltage divided by current. Here it is, voltage, resistance, current. And there's a whole other, look at this whole, oh, look at all the math. That's some fun math. All right, so see this picture? This picture, if you can like kind of memorize this picture, maybe even try and draw it from memory until you get it right. It really explains. Do you see how volt can be seen as pressure?
Yes,
And do you see how amp can be seen as current?
yeah,
And ohm is resistance,
yeah.
right?
It's making it go slow.
Right, so if you keep that image in your mind, that will help you to forever remember what's what.
Why does Ohm look so like worried and shame?
He's very concerned about what he's doing. All right, so series and parallel circuit. So what's a series circuit, Darcy?
A series circuit has only one path through which a charge may flow.
Right, okay. If one element of a series stops functioning in a series circuit, yep, Lewis?
Short circuit.
Yeah, but what I'm looking for here is like if none of them operate. So if one element in a series circuit stops functioning, none of them do. So Christmas lights, the older kind, they've gotten better, especially now that they're LED Christmas lights, but the older kind of incandescent Christmas lights. If one light went out,
The whole thing.
the whole strand went out because it's a series circuit. So back in the, like, if you watch like National Lampoon's Christmas
Oh,
Vacation,
that's
he
Christmas
checks
movie.
every light bulb, right?
We
Because
watched
if
that.
one's out, everything's out. All right, so that is a series
My
circuit.
neighbors had one kind of like this,
Mhm.
except not the whole thing, just after the light bulb that went out.
Mhm. And this is a good example of a series, okay? Now you also have a parallel, ooh, don't know why that, sorry, those are already there.
I won't.
So it's already popped up. I don't know why. They didn't get animated for some reason. So parallel circuit has two or more paths through which a charge can flow. And if one element stops functioning in a parallel circuit, the rest can still keep functioning. Okay, so it's your series circuit that it'll all be done. And your parallel, they can keep functioning. I don't know why all these answers are filled. Oh, that's fun. So a complete path through which a charge can flow is called a, yes, Darcy? A complete
wait,
path
no.
through which a charge can flow
Is a series circuit?
is just a circuit, electric circuit, okay? So circuit diagrams use symbols to represent parts of a circuit, including source of energy and devices that are run by electrical energy. So electrical safety, let's talk.
This is a true thing.
Look at this dude. Oh, boy. Grounding, fuses, circuit breakers, and electric shock. If electric current takes an unintended path, now, Lewis, what's this one?
Short circuit.
That's a short circuit. All right. Care should be taken to ensure that the electrical wires are not exposed or frayed.
Danny,
Yes.
why does it say short circuit and another?
I don't know. I don't know why. I think I just messed that up when I was making it. It should have been on 2 lines, but it stuck it on 1 line. Yeah, so you don't want a frayed wire because then maybe your electricity is going to jump out of that wire onto something else, right? And that's not good. So some electrical cords have, yes, Carlos?
Third prong.
A third prong, okay, which connects an appliance to a building's ground wire. So in the event of a short circuit, Lewis?
Electrical circuit.
Right. And a grounded circuit flows directly into the ground. So there's a wire in your home that goes into the ground, all right? And that third prong is your ground wire. So in the event that you have some kind of a short circuit, all that extra electricity is going to go into the ground. All right, all right, all right. What are metal rods mounted on a roof called, Nico?
Lightning rods.
Lightning rods. Have you seen these?
Yeah.
These are cool, right?
They have them in Minecraft.
Oh, do they? Yeah.
Yeah, I mean,
So it's connected to a ground wire. When lightning strikes the rod, charges flow through the rod into the wire and into the earth. What's the purpose of it? What's
TD.
oh,
No,
Fix
not
itself.
okay. What's the purpose of it, Nico? I mean, Carlos.
The light
Get
hits
twisted.
it and then it flows. The
Right. Why do you suppose it's up on the roof?
So it's closer to the
Because
sky.
it's the
Yeah, you got it. Go ahead, Emma. What were you saying?
so because it's the shortest path to the thing.
Right, right. So, you know, when they say if there's an electrical storm, you shouldn't be like outside golfing, right, Lewis? Like if there's lightning, you guys get the heck off, right?
He's been doing, nope.
You
He's hid under trees with his dad.
under trees, okay.
That's
So
the worst
why,
place to do it.
why under a tree? Is that a good thing or a bad thing to hit under a tree?
That
Why?
Because if they're closer to the sky and it has a more likely chance.
There you go. There you
It
go.
wasn't a lightning storm, it was just a rain. It's also,
Just a rainstorm.
it's also that's why you don't take a shower.
Yeah, that's why some people are like, don't get in the bath or take a shower when there's a big lightning storm, because if it hits your house, what are your pipes made of? Yeah, now in some of these newer houses, there's a lot of plastic piping, so it's not as big a thing. But yeah, in old houses, they're made of copper. And that, yeah, you don't want to be standing in the shower and right? So in order to prevent circuits from, sorry, overheating, devices called fuses and circuit breakers are added to circuits. So what is this thing that we're talking about with a thin metal strip, Emma?
Fuse.
Yep, okay. So a fuse contains a thin strip of metal that if it's overheated, it's gonna melt. Who has seen A Christmas Story? The movie A Christmas Story.
Me.
And Dad runs downstairs to the basement. A fuse has blown, right? Remember? It comes up with like all the dust and stuff from the big coal furnace down there. All right. So go ahead, Nico.
Circuit breaker.
A circuit breaker uses an electromagnet to shut off or trip a circuit.
Oh,
Where is the circuit breaker in your house? Does everybody know where to find it?
Basement.
Usually in the basement or the garage.
And I have like 7 circuit breakers.
I have one in the laundry room in our old house, but this one's in the basement.
Like 7 circuit. I have.
Anybody ever tripped a breaker and then had to reset it?
Ours used to trip all the time when we first moved in.
I had one trip once during lab. We had hair dryers running, I think, in here. And I had like 4 of them plugged in and it tripped the kitchen circuit. So how do you reset a breaker? Do you know? You ever done it?
Yes, you have to go down and you have to like turn all of them off and turn all of them back on. You gotta fiddle around.
How do you know which one it is?
Because there's a red
Because
light.
there will be a light. and
Yours has a light?
off.
Uh-huh. Mine is, they all look like switches. They're all facing one way.
One's the wrong.
One's the wrong way, and you go back, forth, back, and then you slap it back and that fixes everything, right? So that prevents fires and all kinds of other things, right?
Oh,
So your body has many functions which run off electrical charges. Outside currents will interfere with those charges and naturally occurring charges. So the severity of an electric shock depends on the current. This is why defibrillators work. So if your heart rhythm is off or your heart stops beating, they actually can give you an electric shock, which can kick your heart off again, start a normal rhythm again. Yep, right?
Take your heart off.
Uh-huh.
Mime taking a picture,
What now?
like mime taking a picture.
Oh, okay, I've seen this one. Yes, Eunice, show us how you would take a picture. Like mime it. How would you do it?
I don't know, like you need to see the video.
I know.
Yeah, you do like that. People my age go like this. Yeah, there's another one too. There's a bunch of those. They're fun.
I do this.
Yep.
I did this.
All right. So
Just look at that.
lastly, we're going to show you this video about fuses, okay, and breakers and whatnot. If it'll go. Here we go. Fuses and circuit breakers. Sorry about the cough. I can't make it stop.
Wow, Scott, you just, I'm going old school here. You don't do that often anymore.
Well, I work in a lot of old houses, and the other day, I was in the basement, saw an old fuse panel, took a picture, and tweeted it. A bunch of responses.
No surprise, right? I mean, everyone's got some sort of panel in their house. They probably don't think about it that often, but you obviously think about it all the time.
We do. Well, everyone knows electricity flows in our house through wire. The smaller the wire, the less electricity. The larger the wire, the greater electricity.
Makes sense?
If any wire carries too much electricity, it can heat up and cause a fault. This carrying of electricity called current is measured in amps. You've heard of a 15 amp, a 20 amp, or a 30 amp.
Usually what I think about the fuses and the circuit breakers.
That's right. That was the first line of the protection that we had, and we would put them in a porcelain holder like this.
That's old
They
school.
put the fuses in and they would protect the wires going down line. Then they came along with a packaged version of it, where the fuses and everything was protected with the metal nail.
And when you say protection, how is it providing that protection?
So inside this fuse is a metallic strip. The metallic strip melts faster than the copper wire does when it heats up.
So too much resistance means too much heat, and that would literally disintegrate.
That would just separate, burn out, no more electricity can go through the wire.
that was part of the problem, right? Because when one of these fuses blew, you had to get rid of this and you had to put a new one in. If you didn't have it, you couldn't put anything in that circuit and it wasn't working until you did.
If it was 15 or 20 or 30, it didn't matter, they all.
Dude,
Turn it off.
This is
Hang on.
great.
hold on,
It's not even windy outside.
I'm doing it.
No signal, maybe a tower, sorry, not, maybe like a thing came down, but it's not really windy.
No, it's not that. It's just, it's
Wait.
wiggling here. Here it goes. Come on. Oh, maybe not. Come on, do your thing. I'll get this worked out. You know, it's been a fun, not so fun event. Oh, show me. Oh,
My, you know.
Well, show you something.
Starts with an
Something
A.
I wanted.
Ends with a Lexa.
well,
Was doing this, this morning.
Why are we doing
No
this?
signal, no signal.
Oh. When
move this over here and fuss with it for a second. It doesn't like that I'm
when the thing.
touching it. I dare to touch it.
When she must look at me. Okay.
What happened?
Got
to
my
the
light.
thing? What happened to the thing?
Oh, I like
It flows in our house through wire. The smaller the wire, the less.
Tells me it's over there, but it's not over there.
The greater electricity. If any wire carries too much electricity,
Ah, there it is.
Oh, done. Might not be the best idea to put her.
Sort of.
I can't pick it up my
the
nail.
metallic strip melts faster than the copper wire does when it heats up.
So too much resistance,
So like the sound is on.
heat, and that would literally disintegrate.
That would just separate, burn out, no more electricity in the wire.
Now, that was always part of the problem, right? Because when one of these fuses blew, you had to get rid of this and you had to put a new one in. If you didn't have it, you couldn't put in.
Yeah, I know, I got three.
Alexa, turn on the media center.
She must not be named, you can't say.
Anything in that circuit,
I don't know. It's
and it wasn't working until you did.
If it was a 15 or a 20 or 30, it didn't matter. They all fit in the same holder.
They were interchangeable?
That's right. So what happened for us as electricians later on, you could only put the right size fuse in the right size fuel holder
Why is he here?
because of the thread differences.
No, no.
So they have an adapter that you would screw into the.
All right, well, I'll put that up for you guys to see. I don't know why it stopped doing that, but
Shall we call the rest of the truck?
you shall call the rest